This video is about using the normal distribution to go from percentages to z-values. So when we look at this, we're going to use the Excel to do a portion of the work, and then we're also going to use Paint so we can see what we're doing. So one value will be using a chart, another will be using Excel. So graph 1, same problem, so A will do on both of them. That'll be the chart method. This will be the Excel method of doing it. So looking at this, let's look at our first example. We're going to go from percentages to z-scores. So what does that look like mathematically? So 67% is going to have a z less than what value? Or we could have read it the other direction. What is the probability z is going to be less than some number, which we need to find out, and that's going to equal 67%. So said a better way, there's a 67% chance the z value will be less than what number? Having said that, and looking at the curve and knowing that we're dealing with less than, we also know that half the curve is 0.500. So if we know half the curve is 0.500 and the area that we're interested in is 0.6700, when we draw our line, we're going to need to draw it somewhere over here. So we have the full 50% plus an additional 17%. So the additional 17% is going to fall here. So that was, I'm going to highlight the area first. So I'm going to go ahead and shade this in. So what we're looking for is this region here. Now I can type in that there. So this one is going to be 0.1700. Those two added together are 67%. We're doing good. So I need to find the z-score that goes along with it. It depends on what z-chart you're using, but in our z-chart, the z area that we're looking for always goes between 0 and a number. So we're going between our z value of 0 and here. So we're going to look up 0.1700. So you're going to look at the inside of the chart. This is where our probabilities are found to find the z value on the outside. So 0.1700, here it is exactly, is 0.44. So z is 0.44. So in this example here, let's put that in there at the very bottom. We found out that z was 0.44. Let's do that using the Excel method. So the equation that we're going to use in Excel is equals norm.s.inv. We're going to need to figure out what percentage value to put into that. So don't think about what we just did. Think about starting the problem over. So if we were given 67% is to the left of the z-score. So somewhat how we did last time, we said that we only know that's going to fall somewhere over here. And if we were to fill in the areas for that, that's going to be in here. And that whole area that's currently shaded right now is 0.6700. Helps when you actually type it. So 0.6700. All right. Well, the interesting thing about a z-score in Excel is that it always goes from negative infinity up to the value we're looking for to put that in. So the value we need to put in, the highlighted area, we're going to need to put in 67%. So equals norm.s.inv. Put in 67%. You could also put in 0.67 if you wanted to. And it's going to come back with 0.4399. Well, rounded, that's going to be 0.44. So in this methodology, we found out that that was 0.44. So whether you use Excel or the chart method, you get the same thing. So what does that mean? It means that there is a 67% chance the z value will be less than 0.44. Let's move on to the next example then. So I'm going to clear my chart here and open up a blank version of it. So let's look at this version down here then. So what is the probability that we're going to go between some number, z is going to go between some number and 0. So z is going to be a negative value there. and we're going to get a probability of 24%. So 24% is going to go on the top as our known at the moment, and we don't know what the z-value is for our lower value. So let's look at graphing that one. So let's graph it on both of them. So we know that the z is going to be some value less than 0. Some value less than 0. And we know that the area that we're interested, or the area that we know so far, is this piece right here. So this is 0.2400. So let's look at that now. So 24% of the probability, 24% of the probability falls between some negative z number we don't know and 0. How do we use that doing the chart method? So very similar to the one that we just did. We're going to pull up our chart. Because the chart does between 0 and a value, we're going to do 0.2400. That's your probability, so that's on the inside of the chart, and we want the z-score on the outside. So 0.2400 is going to fall between these two here. So 0.64 is closest. So when I look up this value using the z-chart, we found that this one, because it's on the left side, is going to be negative 0.64 standard deviations below the mean. So 24% of the values will fall between negative 0.64 and 0 standard deviations. Let's do the Excel method on the same one. Now, if you remember on Excel, we were given that we know that this area right here is 0.2400. But in Excel, that doesn't necessarily help a lot because what we need to put into Excel is the value between negative infinity and the value that we're looking up. So we want this value right here. In doing that, we need to go, okay, well, that's going to be 0.5 because 50% is on each side minus 0.2400. It's going to give us 0.2600, right? So if we were to put in equals norm dot s dot inv, and we're to put in 0.2600, we would get negative 0.64. We could have done the same thing, norm dot s dot inv with 0.5 minus 0.24, and it would have returned the exact same answer. So you can have it do the calculations within the norm dot s dot inv function. Why did we pick norm dot s dot inv? Well, it's a normal distribution. Because it's a standardized z-score that we're using, it is .s. And then because we're going from percentages to a z-value, we are going to have a .inv. So no matter which method we used, we ended up with negative 0.64 as our answer.